Hi, everyone. My name is Scott, and I am going to be talking for the next little bit about exploring the intersection of ClusterAPI and infrastructure as code and what it might look like when you want to combine these two technologies together. So I hope that you find this session useful and interesting, and I hope that I'm able to share something that's new that you haven't seen before. So let's get started. Here we go. All right, a little quick blurb about me. I do strive to be a lifelong learner. I'm always looking at learning new things, which is one of the things that led me into Pulumi. I was looking for practical ways to help expand my programming knowledge, which I'm still a newbie at, so don't laugh at my code. And I found that using Pulumi and writing general purpose programming code for managing my infrastructure as code was a nice use case that kind of helped me get a little deeper in some of the programming languages. So obviously I am a Pulumi user. I started with TypeScript and then moved to Go. A little secret I'll share with you. The reason I moved from TypeScript to Go was that there was a change in the Pulumi SDK that required TypeScript started using promises and async stuff. And I totally didn't and still don't understand all of it and couldn't make my code work. So I was like, okay, fine, I'll just switch to Go. I wanted to learn more Golang anyway. So it worked out. I do work at VMware. I came in via the Heptio acquisition, and my job there is to help folks with Kubernetes, stand up Kubernetes, optimize their Kubernetes environments, that sort of thing. And sort of related to that, that means that I'm a big fan of ClusterAPI. And I'll talk more about what that is in just a moment. All right. So speaking of ClusterAPI, what is ClusterAPI? It is a project. It's led by SIG Cluster Lifecycle. It's a project to bring declarative Kubernetes-style APIs to cluster lifecycle management. So much in the same way that you would use a declarative API to say, I want to run this container image and I want to have this many replicas of it and I want you to expose it on this port. And then Kubernetes goes and uses its core reconciliation loop to ensure that what you've asked it to do is actually, what's happening, right? To reconcile desired state and actual state. The idea is we can use ClusterAPI to bring the same style of declarative APIs to managing cluster lifecycle. So we can say, I want there to be a cluster and I want it to have 3 control plane nodes and I want it to have a machine deployment that I can scale for worker nodes and so on and so forth, right? And then we apply those definitions, stored in a YAML manifest, that declarative state, we apply that to what is known as a management cluster, and that's a cluster that has all of the ClusterAPI components and controllers and CRDs and such installed. And then again, through that core reconciliation loop, that management cluster then realizes the desired state of saying that a cluster exists and it exists in this configuration, right? ClusterAPI was written in a way that allows you to use different IaaS providers. So there's there's a provider, a ClusterAPI provider for AWS, a ClusterAPI provider for vSphere, for Azure, et cetera, and so forth. And as if it wasn't confusing enough, we have ClusterAPI, which we refer to as CAPI, and then the providers are the ClusterAPI provider for AWS, so it's called CAPA, and then ClusterAPI provider for vSphere, CAPV, ClusterAPI provider for Azure, CAPZ, so on and so forth. Normally, when ClusterAPI interacts with these IaaS platforms like AWS or Azure or whatever, it will go and it will create all of the necessary infrastructure that you need. So you'll give it a manifest. That manifest will define what the Kubernetes infrastructure needs to look like. And then the provider knows what it has to create underneath that to support said Kubernetes cluster. So on AWS, which is what I'll be using today to show off how some of this stuff works, it would go and it would create a VPC and subnets and gateways and route tables and all the necessary jazz. And it'll just do all that for you. And so the idea is that a user could then go and not have to worry about managing infrastructure. They can just do it all through ClusterAPI. However, for a variety of reasons, customers may want to consume their own infrastructure. They may already have existing AWS structures that they want to use. They want to have ClusterAPI simply use those instead of creating new ones. And so there is the model for supporting what we call bring your own infrastructure, right? And which would allow you to say, well, here, I already have a VPC and subnets. I want ClusterAPI to use those instead of creating its own. And I'll show you what that's look like. And in fact, that's going to be a key sort of part of the entire presentation is how we can use a ClusterAPI manifest or ClusterAPI itself with infrastructure created using Pulumi for infrastructure as code. And we'll look at some different ways to do that. If you're interested in more information about ClusterAPI itself, this is just a simple high-level overview. Go to the ClusterAPI homepage at cluster-api.sigs.kates.io or check out the GitHub repository there on the screen. Now, I want to show you real quick before I go on what it looks like to see a ClusterAPI manifest. So let me switch to my demo screen here. Okay, here we go. And I'm just going to manual. I have, here we go, a YAML manifest. This is a ClusterAPI definition. This is a complete definition that will create an entirely independent Kubernetes cluster. And so you can see we have these custom resource definitions that ClusterAPI uses, things like cluster and AWS cluster and kubeadm control plane. And we have various fields that we configure that, what region it's going to be in for AWS, what SSH key it's going to use, so on and so forth. We can specify replicas and versions and so on and so forth, right? And we can map that down to specific instance types. So we could have the control plane. In this case, you see I have CES demo control plane is the name of this object, and I'm mapping it to a T3 large because this is just a demo environment, but I could map it to, an M5, X large or whatever here. And that gives you an idea of what's going on, right? So now let's flip back over to the presentation. Here we go. And with that in mind, then, what does it look like to have ClusterAPI use existing infrastructure, what we call this BYOI, bring your own infrastructure model. So users can create their own infrastructure. They can use an infrastructure as code tool like Pulumi. They can create all the necessary pieces that are there and use all of the best practices that they would want to use for infrastructure as code, right? And then you can integrate that. So, that third bullet there on the screen, is it possible to use IAC for BYOI with CAPI? Yes, absolutely. You can use infrastructure as code to manage the infrastructure that you are bringing into a ClusterAPI environment. The answer to that fourth question, whether I can use even more acronyms than that in a single sentence, we'll have to explore in some other session. Okay? All right. So let's see what we got here. What information does ClusterAPI need about the infrastructure that you're bringing in if you're going to do that? So if you're going to bring in your own infrastructure that you are managing through an infrastructure as code tool like Pulumi, ClusterAPI has to have some of that information so it knows that it's not supposed to go out and create new infrastructure. So what is the information that it needs? I'm speaking specifically here about AWS. So for other providers, it may vary, but each of the providers is pretty well documented in terms of if you're going to do this on Azure, you should be able to check the Azure documentation for the ClusterAPI provider for Azure and see what information is needed, right? For AWS, you have to have the VPC ID. You have to have a list of subnets. Now, there's two types of subnets. There's public subnets and private subnets. And ClusterAPI has a series of checks it uses to determine which is a public subnet, which is a private subnet. You need both. And typically, a private subnet would be a subnet that has to use a NAT gateway to get to the internet, right? So it's not exposing public IP addresses. It's not using an internet gateway. You have to go through a NAT gateway. So you have to have that list of subnets, and ClusterAPI will prefer the private subnets to place the instances that it's going to create. So these machines will be on private subnets. They won't be exposed with a public IP address, and you'll be able to necessarily SSH them directly. That means typically you're going to have something like an SSH bastion host if you want access to the nodes. There are other ways, of course, but an SSH bastion host is pretty common. And in that case, you're also going to need a list of additional security group IDs because ClusterAPI can create the bastion host for you if you want, but you're probably going to be co-locating because you're using existing infrastructure. You're probably going to be co-locating this Kubernetes cluster in a VPC or in subnets that may have other things there. And so you may already have an SSH bastion host and associated security groups. So we use this additional list of additional security group IDs to tell ClusterAPI, put my instances into this security group so they can receive traffic from the bastion host, for example. Now, full details on what is needed to bring your own infrastructure is at the URL here on the bottom of this slide. And it'll give you all the details on what you need to bring and what ClusterAPI will create on its own, right? Basically, what you need to bring is a VPC, subnets, and those security groups, right? And then ClusterAPI will create ELBs as needed. It'll create instances, and it'll create additional security groups that it uses for its own purposes to allow the Kubernetes nodes to communicate with each other, for example. It also, in that document, outlays specific requirements for AWS tags that are required by the Kubernetes AWS cloud provider for it to function correctly. And you do want to make sure that your Pulumi code that creates this infrastructure does assign those tags, or else the AWS cloud provider will fail to function properly, and then your ClusterAPI, or your cluster, won't work like you expect it to work. All right, so I've laid the groundwork for sort of what ClusterAPI is and how we do bring your own infrastructure, and have said yes, you can absolutely do IAC with something like Pulumi and use that with ClusterAPI. Now I want to show you what that actually looks like. So we're going to spend the rest of the time in this session, probably another 10 to 15 minutes or so, actually looking at this through a set of real world examples, right, of potential ways that you could integrate an infrastructure as code tool like Pulumi with ClusterAPI. I've taken all of the examples that I'm going to show you here. They're all in a GitHub repository. You can see the URL here. So it's github.com/scottslow/2020 CES IAC CAPI. I'm very imaginative when it comes to naming things like this. So what we have here is 2020 Cloud Engineering Summit, Infrastructure as Code, ClusterAPI. Very imaginative. So let's look at this in my terminal. I'm going to switch over to my demo terminal here. All right, there we go. And I've already shown you what the base looks like. So I'll just pull this up again. This is the base configuration we're going to be using throughout all of the different examples I'm going to show on how you can integrate something like Pulumi with ClusterAPI. And this is a bare bones ClusterAPI manifest. I created it using the ClusterAPI tool, ClusterCTL. So I gave it some information, like this is how I created it. The information on the specific command that I ran, for example, is in the README in the repository, the GitHub repository that I just shared. And the first scenario that I'm going to show you is this manual scenario. And so in that directory, I have a few files, and this README here is where it'll actually tell you what command I use. Like right there, you can see here's the ClusterCTL config cluster, blah, 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 right? So take a look at that if you're interested in sort of replicating this on your own. The CES demo YAML, that's the base configuration we're going to use. You'll see a customization YAML here. We're going to use customize in one of the later scenarios. So for now, just ignore it. But I already have this stack, and let me see if I can remember. Actually, let me look at my history here. Pulumi, here we go. Okay. So I already have this stack that I am using. I've called it CAPI full BYOI, and it goes through and it creates all of the objects that are necessary to bring your own infrastructure with ClusterAPI on AWS. So it creates VPC, subnets, route tables, gateways, NAT gateways, all that kind of jazz. And then it exports these fields so that we can use them later on. And when it comes to integrating infrastructure as code, like what we're doing here with this Pulumi stack and ClusterAPI, you could do it manually, and you could use a tool like YQ or whatever. Now I have an example of using YQ to pull this information out, right? And I've put them all into a script just for sort of ease of use. So let's take a look at that. So I have some variables at the top that just make it easier later on. You can change these, and the README has information about what needs to be changed if you wanted to replicate this on your own. Keep in mind, this is a total hack. I wouldn't recommend this for real production sort of use, but it will work, and it will give you an idea of one way that you could integrate these two if you're interested. And so I'm using this tool, YQ. There's a link to that, and it's GitHub repository in the README. But what I do is I make a copy of the original, and then I write these additional fields that are necessary for ClusterAPI. One of these is this networkspec.vpc.id. And then I use the Pulumi stack output command to reach into my project, into my stack, and pull out the VPC field that I exported in my code. And then I do the same thing for the public subnets and then the private subnets, or vice versa, private subnets and then public subnets. I tried to use a bash for loop here, but I kept getting errors, so I just hard-coded it. Again, this is an example. It's a hack, right? And what this will do is it will go through and it will write all the necessary fields that are needed for ClusterAPI to use the existing infrastructure, the existing VPC, and the existing subnets. This example does not write any additional security groups in there. I'll do that in another example. So if I run this, It'll take a minute or two to run while it goes and reaches into the stack and gets information out. And then now I see I have a new file called modified. And if I look at modified, at first it looks like it's normal, but then when we get into the AWS cluster object here, so the second document, second YAML document in this file, you can see that this network spec VPC and subnets is added there. And if I get back to the CES demo, the original, and I look there, they didn't exist before, right? So what we've done is we've modified the base configuration so that it has the information we need to use existing infrastructure. And if I were to apply this manifest against my ClusterAPI management cluster, which is where the ClusterAPI controllers and custom resource definitions live, then it would go and it would create a new, what we call a workload cluster, a cluster that it's managing via ClusterAPI, and it would do so in the specified VPC and in the specified subnets. Okay. There's additional stuff, by the way, if you want to distribute your cluster across multiple availability zones, across multiple AZs, there's some additional fields you have to add. The control plane will do that automatically. So if we were to apply this, then we would see the control plane. If there's multiple instances in the control plane, it would automatically distribute them across AZs. Worker nodes are a little different. All this is in the documentation upstream, the link that I gave you earlier, and I'll show it on the screen again towards the end of the presentation so you have it. And then I could just use kubectl to then apply this manifest, right? I could just kubectl apply -f. Now I'm not going to do that just yet because I have another way of doing that I want to show you. But this gives you one idea of one way you could do this, right? Now the other way, one of the other ways, is here. And in this case, what I'm doing is I'm using a Go template that I created from the base configuration. And that's this cesdemo.tmpl. And then I have some Go code that I wrote, and that Go code will generate that template using information from the stack. And to pull the information from the stack, I'm using Pulumi's automation API. So let's take a look at first the template. So this is a pretty standard, Go template. At first you don't see anything here, but then it's all standard, right? But then we get into the network spec stuff, which is where we need it. So you see I have a reference to a VPC ID and then a range object for some subnet IDs. And then farther down here, you'll see me use a field called hack. I'll explain what that is in just a moment. There's probably a better workaround than what I'm doing here, but this is what I had to do for now to make it work. And then farther down, I'll show you, this is where we add the additional security groups. So under this AWS machine template, we have the spec, the template, the spec, and then additional security groups, and we would have a list there of any additional security groups that we needed to add. In this case, there's only one, and that's going to be the Bastion security group that will allow it to communicate with the SSH Bastion. Now let's look at the Go code that I wrote. Again, be gentle. I am a newbie programmer. So first I'll define a struct that has the fields that I'm going to need. And there's that hack field. I'll come back to that in just a moment. I use the automation API to reach into my stack. I then pull out some values that I need. So the VPC ID, the Bastion security group, the public subnets, the private subnets, put those in a combined field. And then down here, the hack field, there's a subsequent round of Go templating that ClusterAPI does when it uses the template to create the cluster. And so what I did here, because I kept getting errors in my Go templating that it didn't understand what DS metadata was, because I'm not passing that data to it. So instead, I replace my temporary field with the ultimate field that ClusterAPI will use. And so where in the template it sees hack, then when I make my templating round, it will then substitute DS metadata local hostname, which is what ClusterAPI will use and require. So then the rest of the code is all straightforward. It just generates the template and off it goes. So let's do this. We know there's no YAML file here, just the template, right? We're going to do a go run main.go. This will execute the code, and it will use the automation API to reach into my CES demo stack, pull out the values it needs, and then use Go templating to generate a template. And so when I look at it here, now I have a YAML file based on that template. And if I look at that YAML file, whoops, helps to type, then we see a YAML here, and we see that we have the VPC spec and the subnets listed. And if I go farther down, Here under this configuration where you see name DS metadata, that's my hack, right? It replaced my hack field with a proper field that the ClusterAPI round of Go templating will look for. And then down here in the AWS machine template, you can see that it populated the security group ID that it needs to communicate with my pre-existing SSH bastion. And so now I could, again, use kubectl apply-f, this YAML file against my management cluster, and it would go in and create that. But I'm not going to do it yet because I have one more thing I want to show you. So let's go here. Okay. So in this last example that I want to show you, I have built on the previous example. I'm still using the automation API. In this case, I have another local project that's stored in this K8s directory, and it uses the Kubernetes provider and its built-in customized support. And what I'm doing here is I'm templating out some customized overlays that will receive the values from the Pulumi stack. Then the Kubernetes provider will use customize to apply those overlays against the base configuration. And that's defined in the customization.yaml file. And that's why we had a customization.yaml file in the manual directory, because that's the base configuration that it's going to be applying against. And then the Kubernetes provider will automatically apply that against my management cluster. So first I'm going to, my SSH channel is probably timed out. So I'm just going to make sure that, yep, okay. So let's reestablish that. Okay, there we go. Now you'll see that I'm talking to my management cluster. I told it to do get clusters. The fact that it doesn't find anything just shows that there are no workload clusters defined in my management cluster. So it doesn't have any clusters defined. And after I run this code, then we're going to do this again and we're going to see a cluster there, which means that it has successfully generated the code and is looking at and is creating the cluster using the information from Pulumi, the Pulumi stack, to populate an existing VPC and existing subnets. But before we do that, let's look at the code. So first, the main code here, this is just an iteration from the previous one. So I still have that same struct because I'm using a template. And then I reference my original stack, my CAPI full BYOI stack, which generates all the underlying infrastructure, pull the values out that I need, just like I did before. And then I define my templates. These are what will become the customized overlays. And then it iterates over that list and generates the templates, and then uses the automation API to drive that K8s stack, which uses the customized or the Kubernetes provider and its customized support to automatically apply this against my management cluster. So let's look at that. So this is a pretty traditional looking set of Pulumi code. I left some comments in there in case you want to try this, but you don't actually want to apply it. You can uncomment that provider field there and the render YAML to directory field, and then change down here on line 21 that you want to use that other provider. That will just generate a set of YAML against a directory, the rendered directory on your local file system, so you can see what Kustomize is doing. I use that to test, but you might also want to use it just to see how it works before you actually try to apply it against an actual management cluster. So we've got our high-level Go program, which is using the automation API. It's going to generate customized overlays and then drive the K8s project to actually apply those through Kustomize. So let's do a go run main.go. The first part of this will run. It'll take a couple of minutes or about a minute, whatever, and you won't see any output. And at this point, it's going and it's generating the customized overlays and getting all that prepped. And then in a moment, we'll see the Pulumi progress streamer pop up. There we go. And at this point, it's going to give us updates. So here it's actually running the customized overlays against the base configuration and then automatically applying them against my management cluster. And it'll take a minute or so, and we'll start seeing some objects populating here. Here we go. And what we'll see when it starts populating objects is we'll see it populating ClusterAPI objects. So you'll see a cluster object, an AWS cluster object, machine templates, control planes, blah, blah, blah. All right, so it creates all those items, says, okay, I'm done. And if I now do my kubectl get clusters against my management cluster, bam, we have a cluster actually provisioning. And you'll have to take my word for it that it's actually going into the VPC and subnets that we specified, and not creating a new set of resources, right? So we are using Pulumi to create our base infrastructure and then pulling that information out from that base infrastructure to give it to ClusterAPI so that it can leverage that. Now, you could obviously take this even farther with the automation API, and you could write a high-level Go program that runs the initial stack. So I created the CES demo stack myself, right? But you could have it run the CES demo stack, then pull the values out, and then run the K8s thing, and it would be completely automated. So you wouldn't have to do anything. You would just run the Go program, and it would create the base infrastructure, and then you could parameterize it so that you could just reuse that over and over again, right? That would be cool. I haven't gotten all the way there yet, but the skeleton of what you see here should give you an idea of like what that would look like. And Evan Boyle, his examples on the automation API are on GitHub. I didn't include a link to that in the presentation, but definitely look at those if you're interested in using the automation API. All right, I'll switch back to the slide deck now. Okay, so that's just a quick demo of some of the ways that you could integrate your infrastructure as code solution using Pulumi with ClusterAPI. And so you could obviously adapt those or use those as a springboard to come up with other ideas or whatever. Just wrapping up then, here's a list of all the resources that I've referenced in the presentation. So all the links gathered together in one place. I also added links to my site where I've done some articles on ClusterAPI and Pulumi. So if you follow those links, you'll get a tags page that just shows all of the articles that are tagged with that particular tag. So all the ClusterAPI articles are all the Pulumi articles. Whoops. There we go. Okay. So thanks for watching. I hope that the session was useful. If you're interested in getting in touch with me online, I'm at Scott_Lowe on Twitter. Feel free to reach out. I'm also Scott S. Lowe on GitHub. Remember, I am a new programmer, so don't expect to find anything like earth-shattering there. But I'm always looking for new resources. So if you are a more experienced programmer and you have some resources you think I should take a look at, then feel free to reach out to me or whatever. I'd love to hear from you. So thanks so much.